Welcome back, guys. In this section of the 12-factor app, I'll be covering the port binding section. So let's get started. Port binding section starts with export services via port binding. So let's see what that is about. So web apps are sometimes executed inside a web server container. For example, PHP apps might run as a module inside Apache HTTPD, or Java apps might run inside Tomcat. So they're saying basically web apps are sometimes executed inside a web server container. There are a couple of examples of that. PHP apps run as a module inside Apache HTTPD, and Java apps run inside Tomcat. Those are the two examples. The 12-factor app is completely self-contained and does not rely on runtime injection of a web server into the execution environment to create a web-facing service. The difference between the earlier examples and the 12-factor app is it completely runs inside, it's completely self-contained. It does not rely on runtime injection into a web server or into an execution environment to create a web-facing service. So at a high level, it's self-contained. So web app exports HTTP as a service by binding to a port and listening to requests coming in on that port. So the web app itself exports HTTP as a service by binding to a port and listening to requests coming in on that port. In a local development environment, the developer visits a service URL like http://localhost to access the service exported by their app. In deployment, a routing layer handles. So let's go back to the first sentence. In the first sentence, they're saying, in the local development environment, the developer visits a URL like HTTP localhost to access the service exported by their app. Okay. In local dev environments, they're showing an example of how the service is exposed. In deployment, a routing layer handles routing requests from a public-facing hostname to the port-bound web processes. So when we deploy it locally, you can use localhost and a port, but when we deploy it, a routing layer will handle the routing requests. So let's say you have a website called helloworld.com, and helloworld.com requests are routed by a routing layer, and helloworld.com is exposed to it's a public facing hostname, so it will be routed using a routing layer to your app's port. This is typically implemented by using dependency declaration to add a web server library to the app, such as Tornado for Python, Thin for Ruby, or Jetty for Java, and other JVM-based languages. So there are a few examples how a web server library is added to the app. So typically it's done using a dependency declaration. And they give some examples here. such as Tornado for Python, Thin for library. I think node-based apps install the HTTP service. So I'm familiar with Node more than these other ones. And then yeah, we create a service using a package, using a dependency, HTTP package dependency, and we create a server and say, hey, we want to listen on so and so port. That's how it's done in a node-based environment. But looks like in other environments also, you could do something like that. We add a web server library to the app. In Node, as I said, we use a package called HTTP to do that. But in other frameworks also, there are other ways to do it. So this happens entirely in user space, that is within the app's code. Yeah, it's done within the app's code if it's a node-based application, or in these other applications too. The contract with the execution environment is binding to a port to serve requests. Yeah. So the contract with the execution environment is binding to a port to serve requests. So HTTP is not the only service that can be exported by port binding. So this is not the HTTP is not the only service that can be exported by port binding. Nearly any kind of server software can be run via process binding to a port and awaiting incoming requests. So any kind of server software can be run via process binding to a port, not only HTTP. So we can do, and they gave some examples of here. The examples include eJabber, speaking XMPP, Redis, speaking the Redis protocol. Okay. Note also that the port binding approach means that one app can become the backing service for another app by providing the URL to the backing app as a resource handle in the config for the consuming app. Yep. So you can have multiple, if your backing app is a service that you're exposing, so it can become a resource for another app. And in the other app, let's say you have app A and B is exposing its service, then app A's config can use B as its backing service by having an entry for that URL in its config. So A's config file will have a reference to the URL for the app B, and that's how app A can access app B's resources. So at a high level, a 12-factor app should be self-contained, and it will expose, yeah. So at a high level, 12-factor app is completely self-contained. It will use packages that are available out there to listen on a particular port if it's exposing any of its services. At a high level, it's self-contained. It uses other packages to listen on a port. That's what port binding is about. It can serve various services like a HTTP service, or they include other ones like eJabber, Redis, for examples. Okay, so that's all we have in port binding. At a high level, again, port binding allow a 12-factor app is self-contained at a high level, and it uses its own ports to expose its services. Let's see what's in the next section. Concurrency. For concurrency, I'll go through concurrency in the next video. I'll stop this video for now.